All right, next one. Here we go. Measurements and rounding. Why do we measure? What's the purpose of measuring? All those things. All right, let's get right into it. Let's go. So what we're going to do here is we're simply going to talk about how to measure, where to measure, what prefixes mean, how to change some stuff. We should be pretty good. So what is the purpose of measuring anything? Basically to give it meaning. All right, to give numbers meaning. Let's even put it in more give quantities meaning. So what we're trying to say is that 23 what? 23 means nothing, okay? That's just a number, right? But if I say 23 years, oh, now I'm talking about time. I know what it's meaning. I know what the meaning is behind it, okay? So science is worldwide, all right? Some might say it's universal in terms of everyone uses it, even people we don't know about that might use it. All right. So science is working worldwide. Why? What system do we use? Well, the world uses the metric system. So that's the system that we're going to use. So the metric system is really based off of values of 10. It's really easy to use. All right. So that's what we're going to do. So what are the types of measurements that science uses? Here are some measurements. Metric measurements we're talking about. All right. So symbol M. Well, that's going to be meters. All right, so meters, we're talking distance, length, height, all that stuff. Lowercase g, that's grams. So grams, we're talking about mass, how much stuff you have in something. The more stuff, the more mass it has. Pascals, PA, is going to be pascals. Pascals measures pressure. It's basically how much force is exerted over a certain area. All right. Capital K. Notice how this is capital P and A. This is capital K. This is Kelvin. Kelvin is temperature. And what's temperature? It's how fast the molecules are moving. So in other words, so we're talking about movement, average kinetic energy of a system. So movement is how fast molecules are moving. MOL, this is a great abbreviation. I mean, it's moles. I mean, it's one letter, not a big deal, but yeah. So moles are amount of a substance. So basically moles is like kind of like dozens and things like that. We'll use moles a lot in chemistry. J, capital J, is joules. Joules is all about energy. How much energy is stored in something, how much it could release. All right, that kind of stuff. So joules, we're really talking about how much heat. We're going to use, we're going to burn stuff and see how much energy in terms of joules is going to be there. S is seconds. Okay, seconds, we also know is time. All right, don't forget time. There's also minutes, there's also hours, things like that. Capital L is liters. All right, so liters, we're talking about volume. Remember, volume is three-dimensional. All right, your glass of water is three-dimensional, so it's a three-dimensional volume. So when you say volume, 1 liter is actually 3 decimeters. It could be actually decimeters cubed or cubic decimeters. Actually, cubic decimeters is the better way of saying it. That's a three-dimensional measurement. 1 milliliter is equal to 1 cubic centimeter. These are important conversions you're going to need to use throughout the class. ppm, parts per million. Okay? And how this kind of works out is basically that's a calculation. All right, concentration, in other words, how much stuff is in a given solution. So the mass divided by the mass of the solution times by 100. Capital M is going to be, we're going to use this a lot, molarity. And it's the same thing as parts per million, just calculated a little bit differently. It's going to be moles over liters. So moles of solute over liters of solution. So these are our metric units. We're going to use a lot of meters, grams, pascals, Kelvin, moles, joules, seconds, liters, parts per million, molarity. Know what they're measuring, because then you give the letters and the numbers meaning. Let's talk about the metric prefixes. In other words, what things you can put in front of meters to give it more meaning or more precise meaning. So how it kind of works is this. Prefix 10 to the third, well, we know that is 1,000. Okay? Whoops, that is not 1,000. That's 1,000, no. That's 1,000. So this 1,000, that means times 1,000, is called kilo. Okay, it's a prefix. So kilo is abbreviated with a lowercase k, like a kilogram. So 1 kilogram is equal to 2.2 pounds. 1 kilometer, 0.06. Notice how we're putting these the prefix in front of the metric symbol. All right, 0, these are going to just be, there's nothing, this is really a no value. This is like a base unit type of deal. There's no real symbol, it's just got to write out what you have. So in this case, we have grams. So how many grams equals how many ounces? 1 meter is equal to 3.28 feet, roughly. 10 to the negative 2 means 0.1. All right, we're talking about this, we're talking about deci. Okay, decigrams, this many ounces, decimeters. 10 to the negative 2, we're going 0.01, one unit smaller, factor of 10 smaller. This is going to be centi. Okay, centigrams, centimeters. You've probably heard centi a lot. Okay, so centi, C-E-N-T-I, if you can't read that. Next one, we're going to go even smaller, factor smaller. This is milli. Okay, milligrams, millimeters. Now we go into big factors, okay? Now we go, I don't know if my pencil's going to write because my pencil's kind of fat. 1, 2, 3, 4, 5, and we got a 1. Okay, this is called micro. So this funky little U with a tail at the front, okay, that's the symbol for micro. So this is a microgram and a micrometer. That's what they're equal to. Then we go even further. Holy cow, it's going to get serious. 1, 2, 3, 4, 5, 6, 7, 8, and then a 1. This is nano. So nanograms. Okay, and this should be an N here. Sorry, misprint. Nanograms. Okay, getting smaller. Small units, really small, precise units. Then we go even farther. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is pico. Pico. Picograms. Picograms and picograms. That didn't make any sense. Why do I have grams? This should be picometers. Sorry. Misprint. Picometers. All right. So these are your prefixes you're going to run into a lot. Pico, nano, micro, milli. You got to know the factor. In other words, to figure out how they're going to do. Couple rules when we're measuring. No naked numbers. What do we mean by no naked numbers? That means numbers need to have labels with them. Okay, always. Years, meters, grams. These are the labels you're going to be using. Next thing when we're doing mathematical calculations, always show all of your work. All right? All right, show all of your work. When we're measuring stuff, okay, when you're measuring, so using a ruler or anything like that, you always measure 1 decimal place smaller than the device is marked. We'll go over some practice with that in a second. Okay, so 1 measurement that's device marked. So here we go. Let's try a couple. If I have this ruler, these are measured to the ones plot. Okay, ones place. Look on the bottom of the page. There's a placeholder if you don't know what the place measured. So if I look here, I know this ruler right here is measuring to the ones because there's 1, 2, 3, 4. That's a ones place. All right. 1 unit smaller would be to the tens, so I have to round to the tens. So this measurement right here, if you can see it pretty good, it's just a little past the 6, not too much. Okay, so it's not quite halfway, but it's not quite, it's not really close to the 6. So a good measurement for this would be 6 point, I would say 3. Okay, and it'd be centimeters. This is measuring to the ones. I estimate or round. Estimate would be a better way of saying it. 1 unit smaller than what this is written. This device is marked. So device is marked to the ones, so read to the tens. So 6.2. Ooh, that was good. I was right on. So 6.2 would be a good measurement. 6.3 would be allowable too. I would see that. So 6.2, 6.3, those would be good measurements. Those would be really good. 6.4, 6.5, those would be, you're not really seeing things right. 6.1 would be too small. 6.0 would be even smaller. So let's try the next one here. If we're looking at this one measured to the tenths. If this one's measured to the tenths, 1 unit smaller than tens, if I look down here, is hundredths. So I have to measure to the hundredths. So I go here. So it's 0.4, but it's not quite to the 0.5, so I know it's 0.4. Let's say it's over halfway. Geez, I would say like 0.47, maybe 0.48. I'm going to go with 0.47, And this is measured in centimeters, so I got to have a centimeter. All right, let's check to see how we did. The device is marked to the tens. Yep, we got that. So read to the hundredths place. All right. The measurement's 0.48. We were right on. So 0.47, 0.48 are good. It's not going to be 0.49 because that would be really close to the line, which this is not. And it's not going to be 0.46 because that would be really close to halfway. So 0.47, 0.48 would be really, really good measurements. All right. When we're measuring volume, all right, here's how volume would work. When you're measuring something in a graduated cylinder, you're going to see a curve at the top. This is called a meniscus. All right. A meniscus, you have to read the bottom of that meniscus. All right, so here's what we got to do. Notice the big lines. They are measured in whole numbers. So 16, 17. But the small ones, so that means I go 1, 2, 3, 4, 5, 6, 7, 8, 9. These are measured to the tenths. So this would be like 16.1, 16.2, 16.3, 16.4, 16.5, so on and so forth. All right, so I know it's measured to the tenths. So it's going to be 16 point. So it's measured to the tenths. So that means I read to the, what's 1 unit smaller than tenths? Look on your thing if you don't know it. Hundredths. So that means I measure to the hundredths. And if it's right on the line, that's fine. And you put it right on the line. So 16, we go 1, 2, 3, 4. The bottom meniscus is right here, so it's on 0.4. It looks like it's right on the line to me, so I'd say 16.40. All right. And usually graduated cylinders are measured in milliliters. So 16.40 would be an awesome measurement for this particular graduated cylinder. All right, so that's how you go one beyond the measurements that are given to you. All right, and that's where we're gonna leave you off right there. All right, so when you measure, it's one measurement beyond the increments, or the device is marked to this, you go one smaller. If you don't know your places, use that. It'll be very, 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 very helpful. All right, so let's try some rounding stuff, which we should have gotten done before. Let's try it out here. So when we're looking at these, we're just going to go through these problems here. This is stuff we just talked about in terms of significant figures in rounding and calculating. When we add or subtract, the least precise number guides you to round. So here's my calculation. 33.5 is to the tenths, plus 7.88 is to the hundredths, plus 0.0977 is to the thousandths. Here's my calculator answer. All right, that's what I'm going to get in the calculator. Now, because the least number to the tenths, that's what I round to. So I go 4.23. Okay, I keep the 3. I look to the next one. Oh, that's a 5. That means I round up. So that would be my correct answer. 42.4, I rounded up from that number. All right, so adding and subtracting, least significant. B, here is, this number is measured to the thousandths. That 3 is in the thousandths. This number is measured to the tenths, and I'm adding them. So this number plus this number, here's my calculator answer. But my least precise number is going to be to the thousandths because it's furthest to the left. Okay, least precise. So that means I'm going to take this number, I'm going to keep the 2 and the 3, and then I'm going to say, oh, the 0's next. That means I just round to 23,000 kilometers. That is my correct calculator answer. 6,070, sorry, is measured to the hundredths, minus 78.7 milliliters to the tenths. Here's my calculator answer. Tenths is my least number, so it would be, hundredths is my least precise number, so 6.7, so then I go, 6.6, I'm going to keep that 6th place, I'm going to have the number there, look to the 2, keep the number. 6,600 milliliters. All right, these are really good examples to look at. And then here's another little practice to give if you guys need more practice with stuff. Multiplication and division. It's all about the number with the least significant figures. All right, so 4 sig figs, 3 sig figs, 67.23, 9.23. Which one's lower? Well, this one has 3 sig figs. Calculator answer, I have to round this calculator to 3 significant figures. So 3.19, look to the 5. 5 is going to round me up to 620 with a decimal. This decimal makes that N0 count. All right. Now, here's something you don't see too much. That number with a line over it there, that makes it significant. You're not going to see it a lot, but you will see it every once in a while. Okay, so that means there's 2 significant figures. That line makes that number significant. Times 3.33. Okay, so I have 2 and I have 4. Here's my calculator answer. I'm going to round to two significant figures. So 66, look to the next number. That gives me a number up. So I'm going to 670 centimeters centimeters squared. All right. 30 divided by 3, one significant figure, one significant figure. That makes it easy. It's going to be one significant figure, which, by the way, your calculator answer is already in one significant figure. So it's just going to be the same number, which does happen from time to time. All right, so here's where you stop the video. Do a couple extra practice ones down here. Hopefully it all works out for you.